Hey folks, let's just do a quick sound check and see if we can get on the way. How are we doing, people, today? How are we doing? Welcome back, Kellen. Welcome back. Minus 1.1 t squared. Let me just make this a little bit bigger there. Hey Daniel, how you going? Right, so as I mentioned to you folks on Tuesday, we're going to start doing some word problems today. Now, you have to be patient with me because I kind of am changing some of these questions on ChatGPT, and of course they some of them don't actually work. Like for example, in this one, it doesn't actually work. So I am just going to probably write over the question just so that we can make sure that it actually works. Hey Blake, welcome. Not today, Sid. I think I've set a goal, which is to finish differentiation in the next 2.5 weeks. So that is literally my goal at the moment. All right, so what I'm going to do is, did you guys want me to go through the question, or do you think you want to have a go at it first? Remember what I talked about, the whole bread and butter thing on Tuesday? It's basically just differentiate, put it equal to 0, and kind of work it through. Now, I've given us a very easy one to start off with. So let me know, maybe give it a go. Just differentiate and see what happens. And then I'm going to try and see if I can generate a couple of more questions like this. Yeah, that's definitely a minus. Sorry about that. Just because plus doesn't actually it doesn't actually work. It has to be minus. So that's why I've kind of written over it. All right. That's too easy, that one. All right. So let's, I'm actually going to go through this with you folks. So we're going to call this problem 1. So what we've got here, hi, awesome, welcome. So notice how they've actually said that velocity function is this. Now what they're saying is that what is the rate of change of velocity with respect to time? All they're asking you to do in that case is just differentiate dv dt. Now, if you think about it, in previous examples that we did, we would do something like y equals 3x squared minus 2x. So when we differentiate this, we write this as dy dx, which is 6x minus 2. Now, let's say if we had something like y equals to 3a squared minus 2a, then we would write this as dy over dA equals to 6a minus 2. So I guess what I want you folks to keep an eye on is how the y and dy is connected, and then how the x and dx is connected. But when there's a different letter, like in, for example, a, we actually write that as dy dA. So going back to this question here, we've got v of t equals 20 minus 3t minus 0.1 t squared. And we're going to put this as dv dt, because think about it like this. V is kind of like the y, and then your t is kind of like your dy dx. So that's kind of the idea behind dv dt. But really, all you're doing is just differentiating it. So when you differentiate this, you're going to get minus 3, negative... Is this going to work out? I hope it's going to work out. I'm worried now. 0.2t. I think I picked a wrong equation to work with this. Give me just 1 second, folks. I just want to actually make sure this equation works, because I get a feeling that we're going to get a negative time, which kind of sucks. See, this is why you don't trust ChatGPT when it comes to these types of questions. 20 minus 3x minus 3x. I knew it. Why did I do that? Plus 3x. Sorry, I know where the mistake is. We're going to change that to plus 3t, not minus 3t. So let's change it to plus 3t. I think that might actually work better, because time, generally you don't want to have time as a negative. Yeah, I apologize about that. So what we're going to do is we're going to keep that as a plus 3 instead of minus 3. So now what we're going to do is to find the maximum velocity. We're going to put that dv dt equals to 0. So then, therefore, 0, 3 minus 0.2t equals to 0. Rearranging it, we're going to get 0.2t equals 0, take away 3. So what we've got is negative 0.2t is equal to negative 3. T is equal to negative 3 divided by negative 0.2. So t is going to equal, can't find things. So we've got negative 3 divided by negative 0.2. That's going to give us 15. Now, Blake, I know you did that right. That's just my fault. I gave you the wrong equation. So we should be looking at 15. So then what we're going to do is we're actually going to put down, so the t is just 15 seconds. So what it's telling us is that at 15 seconds, this car actually reaches its maximum velocity. So we still need to figure out what that is. And we're going to put down v of 15 equals 20 plus 3 times 15 minus 0.1 times 15 squared. And so when we do this, we're going to get 20 plus 3 times 15 minus 0.1 times 15 squared. 15 times 0.1 times 15, 3 and 15. Yep, 42.5. So then we can say the velocity is 42 point, we don't actually have the units, do we? Nope, I'm just going to put it as 42.5 here. Terrible ChatGPT question, but there we go. So Blake, no, you didn't do anything wrong there. It's just my question was, it kind of didn't make sense. How was that? Was that all right? And should we try another word question? Or does anybody need some help understanding what's just happened there? Cool. All right, so what I'm going to do is I'm going to try my luck again. I'm going to see if the next question is going to work like this, but let's have a look. Oh, no. All right, let's have a look how this works. Hmm, 40 minus 3. Okay, this one actually works. All right, so let's copy this. Sorry, folks, just need to be patient with me today because I'm trying to do a couple of things here. But all right, so question 2 should pop up very shortly. There we go. Let's try, you folks try question 2 while I get question 3 ready. But let me just check if it's going to work, all right? Because what we don't want to do is end up doing this and then halfway through realize that, oh, this is actually not going to work. So 3x squared. Yeah, this one is going to work. So have a go with question number 2. when does the water jet reach its maximum height, and what is the maximum height, and then for what values of t is it actually, the water jet actually increasing. So this is just a little reminder of what we learned on Tuesday, as well as just combining it with a word problem. All right, let's have a look to the next one. While you guys do this one, I'll try and work on the next one. I wish this tool was available a few years ago. Would have made such a massive difference. What happened here? I think it's supposed to be h equals to. Sorry, Danielle. That's an equals, just not the bar is not popping up properly. There we go. Sorry, apologies. I just saw that just now in the chat while I was looking at another question. A, B side C. Okay, so let's try this question. Now, before we try this question, what I'm going to show you folks is what happens if you actually draw this in the graphics calculator. So we're going to go into menu, we're going to go into graph mode, and we are going to actually draw this. We're going to go 40x, we're going to go 40x minus 3x squared. We're going to click on draw, and then we're going to click on G-solve. When we click on G-solve, you should see something that says max. So we're going to click on max. And there is your answer there, Blake, 6.667, and y is 133.34. So super annoying that you actually have a nice calculator that can solve it straight away, but it, it's just for you to actually check it. But let's actually do this question. So we've got h equals 40t minus 3t squared. So then h dash is equal to 40 minus 6t. We're going to put h dash is equal to 0 for max. So 0 is equal to 40 minus 6t. 6t equals to 40. T equals 40 over 6. I mean, I could actually kind of round this up to, what is it, 6.667. But I might just leave that like that as 40 over 6 for the actual working out. So now I'm going to go figure out what the actual height was. So that's going to be 40 times 40 over 6 minus 3 times 40 over 6 squared. So what I'm going to do here is I'm going to go into main menu, and I'm going to put down 40 over 6 as my answer. And this is something that you can do. So because what I can then do is I can go 40 times the answer, which is 6.667, minus 3 times answer squared. And that's going to give me 133.33 meters. Let's go with meters. No, it does say meters. So I've just done part B. Now for part C, it says for what values of t is the height of water jet increasing? For what values? is it increasing? Now this is a negative. Yeah, it's interesting, eh, Blake? I mean, I would have actually, I wouldn't have put that as H, Blake. I would have actually put that as T. We're gonna assume that this water is on its, the time is only starting from 0. Because of that, I guess you folks are correct, because I would probably put this as, sorry, this is B, this is A. So because this is a parabola that looks like this, but what's happening is it's kind of starting at 0 when x equals to 0, y is equal to 0. And we're going to assume that time can't be negative in this case. And because this particular time is 6.67 seconds, and it's increasing from here to here, I would probably put this as what you have folks done as well. So between 0 to 6.67 seconds. So Blake, you had the right values, but what you'd had was you had h there, and that's got to be t, not h, because h is the actual height. It's all right. We learn, my friend, we learn. Okay, let's see if I can get the next question. All right, question number 3. I will write the formula out properly for you folks. So this actually says area equals AB sine theta. All right, let's see. I'm going to try and see if I can find another question. Germination rate. Hey, Cosmo. Don't know who that is, but... All right, feel free to throw up the answers, guys, for number 3 here. I'm just trying to set up the next question. Kind of having a little bit of issue with it. Where is this? 2e to the power. All right, folks, let's actually go through this one. Luke, in under level 2 playlists, you probably will find systems of equations. So it is there somewhere. All right, let's actually start doing going through this question. Now we've got length of A, which is equal to 20, B is equal to 25, and we don't know what the radiance is, but we're going to do this. I mean, let's try this out. So we've got area equals 20 times 25 times sine theta. So area equals to, what is it, 500 sine theta. So when we differentiate this, so we've done that first part, area equals 500 sine theta. Area dash is equal to 500 cos theta. I hope this actually is going to work out, but let's see. Now what we're going to do is we're going to put area dash is equal to 0 for maximum, which means we're going to say 500 cos theta is equal to 0. Then cos theta equals 0 divided by 500. So then cos theta is equal to 0. Then theta equals inverse cos of 0. Now, depending on whether you work in angles or radians, and I think in this one we're going to be working in radians. Yeah, we are working in radians. So first check that your calculator is in radians. So click on Shift menu, Setup, to check that it's in radians. Then what we're going to do is we're going to go Shift cos of 0. And as you can see, you're going to get theta is equal to half pi. So with that in mind, we're now going to go find the area, which is 500 times sine of half pi. So we're going to go 500 multiplied by sine of the answer, which is half pi. So as you can see, I am going to get maximum area is equal to 500 units squared is what I would actually say. So let me know how that went, folks. Trying to figure out the next question, and it is super annoying. Oh, yep. Let's have a look. Where is it? I don't know if I can put that and as well as the I don't know where I put it. I think it might be in the main recording. Oh yeah, here we go. Yeah, so there's your sine theta that just differentiates to cos theta. All right, let's ask for it. Give me a with what? All right, I think of trying to generate another question here at the moment. PE 50 E negative 0.32T. I just want to check if this actually works or not, because sometimes I don't want to give you folks questions that end up not working, because that's just like stink. Why would you not do this? No, don't. Can you do another trig one? Okay, let me see if this one can give me one with functions. Sorry folks, just generating the question. Sine pi. Okay. Ignore question A. All right, yeah, it's just generating. Hold on. Okay, here's another trig one coming, folks. So, don't know why the equals does that. So what we've got here, this is question 4, is it? I don't know, I can't remember now. Yeah, question 4. Cosmo, it's because I don't really care how many subs there are. People come, they come. They don't, they don't. It's no big deal. Cosmo, it's pretty, I don't know who you are at school, but it's pretty good that you actually have 1K subs. That's pretty amazing that you've actually got 1K subs at that age. Hey Swant, how are you doing? Let me make the trig equation a little bit more challenging. All right, let's see how this question goes. At the moment, Richard, it looks like it is happening. Oof. This is a nice one. Actually, no, this is a nasty one, but I just want to see if this actually works. Oh. No. Uh, 50 sine. Okay, sorry. Richard, I think there is a date. I think it's happening in a few weeks, but I just need to confirm with my own timings, and once that's sorted, I should be able to kind of confirm and let you know. I'll probably definitely advertise it on the channel itself. Like I'll put it up on Insta when I'm on the way. Well before, so there's plenty of notices. All right, let's have a look at this one. I think Richard, let me just check my emails. I don't know which email did they send it to me in. Rangitoro. Oh man, no, I don't really have the full plan yet, but definitely happening. Richard, definitely happening. but I'm just trying to work out how much time I could end up being. I'd like to spend at least more than half a day, but let's see how that goes. All right, so we're going to get through this one. We're trying to figure out the times when the noise level was its highest. What was the maximum noise level reached? So we're going to actually work this out. So we've got n of t equals 30 plus 20 sine pi over t over 12. We've got a few different answers. That's good. We're going to differentiate n of t. When we differentiate this, we are going to get 20 cos pi t over 12 multiplied by the differentiation of this, which happens to be pi over 12. Now, this is really strange. I have a feeling this is not going to look very good. And again, apologies, folks, because this is what happens when we get questions out of ChatGPT. It's just not been so much fun. Have I done this right so far? Yes, I have. So the next thing we're going to do is we know that this is now equal to 0. Cos pi over t. Oh, man. Did you guys get t as 0? Because sine of... You got t equals to 6 seconds. How did you get 6 seconds? Max noise is 50, I think. Yeah, I think 50, but I want to know how you actually ended up with 6 seconds. Am I doing something wrong here? All right, so let's say we put this as 20 pi over 12. Oh, I see. Okay, yeah. I see what happened. Cool. Equals to 0. Then this entire thing just disappears to become 0. So then pi t over 12 equals cos -1 of 0, which I think we already found out before. Need to switch to the other screen here. So it's just going to be half pi. So we've got pi over t over 12 equals half pi, and so we can see that t is equal to 6. Yep, you folks are right. T is equal to 6. All right, so the next thing is that we now need to figure out what that is. So n of 6 is equal to 30 plus 20 sine pi times 6 over 12. That's going to equal to 1. So n of 6 is equal to 30 plus 20, which is equal to 50. Right, Cosmo Place. I know I'm just trying to do some work here, so yeah, 10 minutes should be good. So we've got n of 6 is equal to 50 then. So we're happy with that, folks. All right, let's actually pull up some exam questions, eh? Let's pull up some exam questions from last year. Last year, 2023 differentiation. I'll see if I can find a question that's kind of similar to this. Find the coordinates of the stationary points and identify their nature. No. Parallel. Those are achieved questions. I'm looking for theoretically merit questions, and I can't seem to find any in this particular paper. All right, actually, now let's try this question here. Find the coordinates of the stationary points. No, not that one. No, I'm gonna go back. Sorry, folks. I'm gonna go back to 2022 and see if there's a. This is why word problems are just super annoying, Because coming up with the word problems is just a pain. No, that's parametric. No gradient. No, that's not gonna work. That ain't gonna work as well. No, rate of change. Man, these are all excellence questions or merit questions. Going back to 2021. Now, Jacob, you just got to keep practicing, like Richard said. You know, I think the more practice you do with these types of questions, they start becoming a lot easier. See, like all of the questions that I'm seeing at the moment are like parametrics. Oh yeah, let's try this one here. This is a good merit question. Let me throw it up here. Sorry, I wasn't prepared today because I had a few things that I was taking care of, and then next thing you know, I let time slip. Came home and I was making t-shirts with my kid. That was fun. All right, try this one. This is actually from 2021. This is a merit question, so it's actually worth 5 points. Let's give that a crack. All right, and again, this is stuff that you actually know. It's not actually asking for the y coordinates, it's just asking for the x coordinates. So give it a go. I'll just go grab a drink. Yeah. No, I'm good. And I'll see if I can get a similar type of word questions, because all of these ones, they look like level, kind of like the level 2 wordy questions where you just differentiate and put it equal to 0. Oh, and I got one more after this. We'll do one more merit question after this. That's a good one as well. So if you need a hint for this particular question, remember that it is using product rule at the moment. So if you have forgotten the product rule, by the way, it is if y equals to fg, then y dash is equal to f dash g plus fg dash. Just a little reminder of product rule for you. Negative 0.5 and 1 are two values of x. Haven't found all of them yet. Alright, what we'll do is we'll actually kind of open this up on Desmos as well, just to have a look at it. Do we? No, let's... Desmos, graphing calculator. E to the power of x to the power of 2. Yep, that looks about right. I mean, let's have a look at it. I'm going to start doing this question, folks. So I guess the first thing I want to do is I'm just going to put this in the calculator and the graph and see what it looks like. So I've got bracket 2x plus 3, bracket shift e, wherever that is, I can't see it, there we go, shift e to the power of x, and I'm going to put that as x squared. So I think I know where my syntax error is. No, no. How do I exit? There's an extra bracket there. I just need to make sure I put this bracket in the right place. There we go. That should be better. Okay, so as you can see, those are my two graphs there. And remember I talked to you folks about the gsolve button. You can actually look for gsolve and look for max and min. And in this case, you can see how it's negative 0.999. Now this is where the graphics calculator sometimes is not as accurate. If you go gsolve minimum, that's coming up right as negative 0.5. But if you look at gsolve maximum, it's actually coming as 0.999. So how do we actually solve this? Because we've got the two values, but we still need to show the working. So we're going to put down f is equal to 2x plus 3. F dash is equal to 2. G is equal to e to the power of x squared. So g dash equals e to the power of x squared multiplied by the differentiation of whatever's there, which is 2x. So let's put this together. We've got y dash equals f dash g plus f g dash. So f dash is 2, g is e of x squared, plus f is equal to 2x plus 3 multiplied by g dash, which is 2x e to the power of x squared. So what I'm going to do at this point is, of course, I've got to actually put this all equal to 0, because that's when for stationary points the gradient is equal to 0. So I'm actually going to put down 0 is equal to 2 e of x squared plus 2x plus 3 multiplied by 2x multiplied by e of x squared. Now, because e of x squared is a common factor, I am actually going to take that out. And what I'm going to end up with is e of x squared multiplied by, oh no, I've got another question there, 2 plus 2x plus 3 times 2x. So basically what I've got here is I'm going to do a couple of extra steps here. I'm going to put this as e of x squared, and then inside here I'm going to put this as 2 plus 4x squared plus 6x. So then I can say e of x squared is equal to 0, or 4x squared plus 6x plus 2 equals to 0. Now if e of x squared equals to 0, well, that's not actually going to work out. So then I'm going to work out the quadratic. I'm going to go into polynomial, degree 2, and I've got 4, 6, and 2. I have a feeling I've made a mistake somewhere. No, there's my two answers. So x is equal to negative 0.5, or x is equal to negative 1. So in this case, it's not possible, so we're not really going to worry about it. And therefore, we've actually got our two values for our stationary x coordinates for the stationary points. Now this type of question is worth a merit, so it's like 5 points. And as you can see, like the part where people kind of mess up is recognizing that it's a product rule. Sometimes they don't actually see that as a product rule, and then they make mistakes. The second thing is that they don't understand how you can actually take e of x squared as a common factor and kind of get rid of it. Now let me know if there's any questions with this, and then we'll try and do one more question after this. The reason e of x squared is not possible, let me just see if this is going to work or not. All right, so when I draw e of x looks like this, right? So what's happening is that e of x can never actually equal to 0 because there's an asymptote right there. But if I put that as e of x squared, so as you can see, e of x squared is never going to equal to 0 ever. It just doesn't work out like that. So because of that, you can't actually have an x value where e of x is equal to 0. So the graph actually looks like this. Symmetrical, and it just never comes near 0. All right, now if you do have a doubt about that, then what you could always do is go back to your calculator, and you can actually just draw that graph. So if you go into graph, and I'm going to see if I can try and edit this, but there we go, e of x squared. If I draw it, as you can see, it is not actually touching the x-axis at all. So that's why it's not possible. All right, so last question of the day today. So this is going to be question 6. Let me just readjust it. Give me a second. And again, this is another merit question. Can't remember which year, but give it a go. And if you've forgotten, the little hint, if you remember, for anything to be increasing, gradient has to be greater than 0. So that's the clue I'm going to give you. Try this out. And also remember that this is quotient rule. So if you've forgotten quotient rule, if you have y equals f over g, then y dash is equal to f dash g minus f g dash divided by g squared. So that's pretty much all the hints you need for this question. Give it a go. How long have you been typing that, Cosmo? X and x squared over plus 4 minus 2 and 2. And remember, folks, for this question, like if you can get the differentiation part of it correct, you can actually get an achieved for that as well. So I think one of the things about differentiation paper is that you can't actually leave anything empty. All right, so just make sure that you know, even if you don't know how to answer the question, you can always just differentiate, and you can still get like achieved for it. Cosmo, I'm not smart, man. I just work hard. How long should I give you, folks? I'm going to give you another 1 minute, folks, and then I'll go through the answer. Sorry, I forgot to put the clock there. Usually we have the clock up and running. Yes, got your gear, Cosmo? I got mine sorted yesterday. Which kind are you in? What's when 1 over x is equal to 0? Ooh. 1 over x equals to 0 is not going to work, Daniel. Come on, Cosmo, you got to get our kind up there. Okay, now Swant, we're getting the values. I'm just worried about the values there. We're looking for increasing, Swant. All right, let's start doing this question. All right. So we have got f is equal to x, so f dash is equal to 1. Then we've got g equals x squared plus 4. G dash is equal to 2x. I'm getting 1 over x squared. Oh, okay. Let's see what happens here. So we've got y dash is equal to f dash, which is 1. G is x squared plus 4 minus f is x. G dash is 2x divided by g squared, which happens to be x squared plus 4 squared. Now I'm going to start simplifying the numerator there. So the numerator, I'm going to get x squared plus 4 minus 3x squared over x squared plus 4 squared, like that. So doing this, I'm going to get y dash is equal to negative 2x squared plus 4, and then that's over x squared plus 4 squared. So remember, for increasing functions, we want the gradient to be greater than 0. So we're going to get negative 2x squared plus 4 over x squared plus 4 squared has to be greater than 0. Now cross multiplying this, we're going to get negative 2x squared plus 4 is greater than 0, because 0 times x squared plus 4 squared is equal to 0. So this is what we're going to end up with. Oh, sorry, you're right. 2x squared. My bad. I don't know how I did that. So that should be minus x squared. Is that better? Yeah, silly mistakes. All right, so negative x squared plus 4 is greater than 0. Now, this is when you got to be very careful, right? So, and I've taught you guys this before in with the level 2, like some people have done it with the graphs. So what you do is you can actually do this in the calculator, because I would just go, right now I'm looking for negative x squared. So negative x squared plus 4, and I'm going to draw it. And this is what my graph is actually looking like, right? Now I want to know when is it above 0. And as you can see, I need to figure out what this point here is and this point here is. To do that, I can click on gsolve and click on root. So that first point is negative 2, and the second point is positive 2. So what it's telling me is this graph here is positive between negative 2 and positive 2. So if we go back to our final question, which is negative x squared plus 4, when is it greater than 0? We would actually say that it's greater than 0 for negative 2, when x is actually between negative 2 and positive 2. So that final answer is what we're looking at, and I think this is a merit question at this level. You could have done it either way, Swant, but wait, hang on. I think you can't do it the other way, because if you do it the other way, then it's going to be decreasing. How do you know not to change the sign when you multiply by the 0? Jacob, I'm assuming you're talking about the greater than symbol. I see, Daniel. Yeah, Jacob, now the only time you do that is when you multiply or divide by a negative number. Now, x squared plus 4, if there was a negative down here, like this, sorry, I'll put in a different color. If there was a negative here, then we would actually, because we're multiplying by negative, we would actually change the sign. But because there is actually no negative in the denominator, the sign will actually stay the same. Swant, I think you actually went the other way. For you were the range you gave me, Swant, was actually for decreasing, because when you said x is less than -2, so here you can see when x is less than -2, the gradient is negative. When x is more than 2, the gradient is actually negative. So it's actually decreasing. So the range you gave me was actually for decreasing, and the question is actually asking for increasing. All right, folks. Hopefully that kind of, like what we'll start doing is we'll start doing more exam style questions, so that you kind of get the hang of it. As for what's coming up next, the word problems is not going to go away. Look, we're definitely going to be doing more of it. But we're going to be doing stationary points next. We're doing more of it. Can we do less of it? Well, I think you've done increasing, decreasing. Oh, this stuff, concavity. Or do we do points of inflection? Now, I think we might actually go straight into points of inflection and maximum and minimum points. Yeah. Yeah, we'll definitely go to maxima and minima for the next session. And we'll just continue chipping away at this, like maximum and minimum points. And then after that, we've got, what do we have? Applications. We've got more word problems coming after that. So come Tuesday, we've got a lot more word problems. Then we've got more word problems. Oh, it's going to be a lot of word problems coming up. Jacob. Oh no, I answered that. Yeah, Elijah, I think you just got to be careful with that. Like, I think it's just, you have to do a few of these increasing questions, and I think once you get the hang of it, like I'm happy to do a few more next time, but what we'll do is we can actually look at some old exam papers and actually try do a few more of those. All right, guys, I think that's us for today. We'll catch up on Sunday. I think, what did I say Sunday we're going to do? Maxima and minima. That's the one. We'll actually do maximum points and minimum points, and we'll do points of inflection. I think we'll try and wrap up all of that in one shot, so that we can kind of get on with the more serious stuff, which is the word questions. See you, Cosmo. No worries. Who's our regulars that we missed today? Oh, trust me, Richard, we're definitely coming to triple chain rules. I think you have to do that, because it's just too much fun not to do it. No worries, Sienna, you're welcome. Oh, I got messages popping over work. All right, Rob. Next job, next job. Swant, I think I am. Just working out the finer details. Oh, Richard, you're from Rangi. I think Kellen is from Rangi as well. Kellen was here. I think Kellen might have gone as mine, but Richard, I might have to write this down. When I visit Rangi, I need to see Richard and Kellen. When I come to Mags, I should see Swan. Yeah, see, there you go. Kellen's still here. Sienna, triple chain rules are just the most craziest things, but when they work out beautifully. Swan, now I think I might be crashing a yet. I shouldn't say. No, I'm not going to say much. Yes, Cosmo, This is funny, right? Because I think Cosmo, I know you're in my Kainga at school, but I don't even know what year level you're at. But yeah, I do visit schools as well. This is the most random topic because it's funny. I actually like it. I like the anonymous at being anonymous at school. I'll share something with you, Cosmo. Here, check this. Let me see if I can open this up. I don't know if it's gonna show it or not. Let's have a look. Ah, here we go. There you go, Cosmo. That was me last year. Pakuranga, and then this was at Papatoi, Papai. This one I went and visited Westlake, which I never did the video for. I was supposed to do that. Just yapping away. Yeah, that's just me, mate. Just having a bit of fun. Right, team, I've got to get going. I got my next project that I need to be working on. Richard, Kellen, we'll continue this conversation, and I think it'll be lovely to see you folks when I visit you guys in a short while. I know, Richard. Kellen's pretty interesting fellow there. He's been getting some of these things right as well. Right, catch you guys. Yep, gotta go. See you Sunday. Yep, take care till then. And remember, pink shirt day tomorrow. Don't forget, because I've got my gear ready. I gotta show you guys. Look at this. That's my t-shirt tomorrow. This is my t-shirt, and then this is my son's t-shirt. We both made t-shirts, and then now he's obsessed with making t-shirts. So we've been making like Pokemon t-shirts, but anyway, yeah, don't forget, pink shirt day tomorrow. Wear it, enjoy it, and I will see you folks Sunday.